Okay, the next part over here, we're going to talk about relationship between two planes. Okay, for relationship between two planes, essentially we have only two kinds of relationship. Okay, one, plane one and plane two are parallel. Okay, number two, okay, they're going to intersect the line. Okay, so this one is no intersection, they are parallel plane. Okay, then over here is number two, they're going to intersect at a line. Okay, obviously there's a third kind. Third kind is actually the planes are the same. Okay, planes are the same essentially just means that the planes are parallel and the normal and the constant at the back is the same. Okay, so you just have to compare the normal, compare the constant. They are exactly the same means that the planes are the same. Okay, but generally it still fall under the parallel planes over here. Okay, so determine the relationship between the points of pairs of planes over here. If they intersect, find the vector equation of the line. Okay, so how do I determine if the planes are parallel? Okay, what I need to do is very simple. Okay, so over here I'm going to quickly show you the answer that plane 1 and plane 2 are parallel. Okay, not that I'm going to show you an answer, but I'm going to just tell you the answer straight. Okay, what you need to do is, okay, you need to convert your plane 1 to scalar product form. Then, by comparing your n1, which is your normal of a plane 1, and your normal of a plane 2. Okay, if they are scalar multiple of each other or they are the same, okay, or they are just opposite of each other, essentially it just simply means that the planes are parallel. Okay, so this one is parallel. Okay, so just quickly pause the video. Try doing up to see whether you can prove that these two planes are parallel. Okay. Okay, over here, okay, I have given you another plane equation and two planes equation. Okay, so we're going to determine if the planes are parallel over here first. Okay, very simple. The first plane equation you should able to convert to the normal. Okay, I'm going to leave it there to you. So you can pause the video, try convert it to your scalar product form first. Okay, once you're done with the scalar product form, resume the video. Okay, you should determine that this is, rather you should calculate out the scalar product form of this plane to be r dot 1 minus 1, 3 is equal to minus 4. Okay, so you can quickly compare your plane 1 and plane 2, the normal portion. Okay, you should see that they are not parallel. Okay, so I can quickly say that, okay, plane 1 and plane 2 are not parallel. Okay, which means that, okay, they're going to intersect the line. Okay, there are two methods to find intersection between two planes. Okay, I'm going to quickly show you how do I find the intersection between two planes. Okay, number one is using the GC method. Okay, GC method, first one, I'm going to convert them to your Cartesian equation for both. Okay, so I just change it to Cartesian equation. So plane 1 is x minus y plus 3z equal to minus 4. Okay, plane 2 is x minus y plus 2z equal to 3. If you don't remember how to change the Cartesian equation, kindly refer back to the previous video. You should not forget if you have actually do a one sitting kind of lecture throughout. Okay, so convert both to Cartesian equation. What I'm going to do is I'm going to use my GC. Okay, under your apps poly simultaneous equation solver, go ahead and try to solve the simultaneous equation. Okay, you can pause the video and try finding the simultaneous over here. Okay, I'm just going to show you. Once you key into your GC, okay, you should see this in your calculator. So you should derive this as x1 17 plus x2 equal to x2 and x3 equal to minus 7. Okay, now this will represent a line equation. So how do I present my answer? Simply just using GC. Okay, line of intersection will be L. R is equal to 17 0 minus 7 plus lambda. Okay, since the question already used lambda in the equation, let's not use lambda over here. Okay, we can use alpha, beta, s, t, u, v, doesn't matter, so long as it's not lambda and mu. Okay, 1, 1, 0. Alpha is element of real number. Okay, how do I actually do this? Okay, very simple. Okay, you can take x2 as your alpha. Okay, then the point over here, 17 minus 7, obviously x2 there's no point, so you can take this as the point of the line. Okay, so using GC, you can immediately find your line of intersection very easily. Okay, GC method is very straightforward. Okay, generally it's about 1 to 2 marks. You should be able to find the line of intersection. Okay, there's a non-GC method. Okay, take note, non-GC method, you have to learn it as well, unfortunately, because what happens is that I can actually give you unknowns in the normal and ask you to find a line of intersection in terms of unknown. Okay, so I'm going to show you the second method, which is a non-GC method. Okay, so very quickly, I'm just going to try to draw out. Okay, you see whether you can visualize or not. Let's say this is my plane 1, and let's say this is my plane 2. Okay, plane 1 normal is this, N1. Okay, plane 2 normal is this, N2. Okay, when you cross N1 and N2, you will get a vector that is perpendicular to both N1 and N2. Okay, essentially, if you can visualize, you should see that this N1 cross with N2 is actually parallel to the line of intersection. Okay, I repeat again. When you take normal 1 cross with normal 2, the vector over here is actually parallel to the line of intersection parallel, or the direction of the line of intersection. Essentially, we can say that the direction of the line of intersection is N1 cross with N2. Okay, once I get the direction, okay, what I can do is you just quickly take R dot N, D1 cross D2, you should derive as 1, 1, 0 as well. Okay, if not, you might get -1, -1, 0, but essentially they're the same thing because the direction of your line, the normal of your plane, you can always bring out the scalar multiple. Okay, once you get the direction of the line, to form the line of intersection, okay, we need another point that lies on the line of intersection. Okay, so just quickly show you. Okay, let's say this is my line of intersection. I will need a point that lies on the line of intersection. And this point will actually lies on both planes. So what I'm going to do is, I'm going to let A be a point that lies on both plane 1 and plane 2. Okay, what happened is that, okay, a lot of students from here will be a little bit lost. Okay, if you let A be equal to x, y, z, okay, let's say, okay, if I let A be equal to x, y, z, okay, what I'm going to do is I'm going to sub into both my plane equation. You should see that I'll get x minus y plus 3z equal to -4. I'll get x minus 2y plus 2z equal to 3. You will be back to the exact same thing as your GC method. Okay, so what I'm going to do is I'm not going to let A be x, y, z, because I will not be able to do it. Okay, I will not be able to solve without using my GC. So what I'm going to do is I'm going to let point A be equal to x, 0, z. Okay, I purposely let one of the variable be 0. Okay, you can also use 0, y, z, or you can also use x, y, 0. Okay, one of them, any of them will do. Okay, but sometimes, okay, it's a little bit of luck kind of thing, a little bit of guess and check. Okay, sometimes you might not be able to derive a solution if you use one of them, so you just need to go and swap accordingly. Okay, why I purposely let one of them be 0? Because I only have 2 equations. So assuming I'm going to use the first one, okay, I'm going to take x0z dot with my 1 minus 1, 3, which is my first plane equation. I'll get -4. Okay, from here, I should derive that -4x plus 3z equal to -4. That's my first equation. Okay, if I sub into my second plane, dot with 1 minus 1, 2, I will get 3. Okay, from here, I will derive that x plus 2z equal to 3. Okay, so you realize that I can only form 2 equations. Hence, I can only afford to have 2 unknowns. Okay, by solving simultaneously, okay, I should derive as x to be equal to 17, okay, z to be equal to -7. Okay, if you cannot derive, kindly check your working. You should be able to derive these 2 values. Okay, so once I have the point, okay, so point A will then be equal to 17, 0 minus 7. Okay, I will have the direction as well, which I have found previously. Okay, my line of intersection immediately will be L, R equal to 17, 0 minus 7 plus lambda 1, 1, 0. Okay, same thing, we have used lambda already, so let's not use lambda. Alpha 1, 1, 0. Okay, so this is the non-GC method. Okay, please take note, you have to learn how to find this method as well. Okay, that's just a quick reference back to our GC method. Okay, you do realize that the GC actually also take one of the point B0. Okay, so essentially your GC is actually doing the same thing as you are doing using your non-GC method, okay, which is the algebraic method. Okay, so take note, okay, 2 steps, you find the direction of the line intersection by crossing the 2 normal. Then you let a point that lies on both planes, okay, you let one of the variable be 0 and go and solve simultaneously. Okay, that's all for the relationship between two planes and how to find the line intersection between two planes as well. Okay, take note. Okay, the next portion in the notes is actually relationship between three planes. Okay, relationship between three planes is actually out of your syllabus. Okay, which means that question will no longer give you three plane equation and ask you to determine the relationship. However, okay, certain questions out there, okay, especially prelims, A level we still don't know yet because there's only a few years to take a look. Okay, might require you to sort of visualize how the three planes will intersect. Okay, so for example, I can ask you to find a reflected plane about a plane. Okay, then you have to sort of kind of visualize how does a plane interact with each other kind of things. Okay, so this is a good point of reference. There's no need for you to memorize, but it's a good thing to know as well.